Experiences are what people love the most about travel. Viator is a website and app where you can book travel experiences like hiking Mount Kilimanjaro in Tanzania or enjoying the views while cruising on a catamaran in the Caribbean. They offer everything from simple tours to extreme adventures. With over 300,000 bookable experiences in 190 countries, there's something for everyone. Plus, Viator's travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. When you book a travel experience with Viator, there's always flexibility and support with free cancellation, payment options, and 24/7 service. Download the Viator app now and use code Viator10. That's Viator 10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, and thank you for joining us on episode 249 of the Space Nuts podcast. I'm your host, Andrew Dunkley. I didn't want the job, it just got thrown at me, but here I am. Yes, I did want the job. And my partner in crime here on Space Nuts is, of course, Astronomer-at-Large, Professor Fred Watson. Hello, Fred.
Morning, Andrew. How are you doing?
I am well, thank you. It's good to talk to you. And we've got a lot to celebrate today because we have cracked 1 million downloads as of last week. Since January of last year, 1 million downloads of the podcast on our current platform. And then we went back and thought, well, I wonder how many were before that. And so it does actually look like we've certainly surpassed 2 million downloads since we started, which is just extraordinary. So a big thank you to everybody who has, downloaded once or 1 million times. I don't, whatever. We appreciate your support, our listeners in general, our patrons, for putting a few bucks in here and there. It's just fabulous. And I never thought I'd see the day where I could boast 1 million downloads of the podcast. Yes, indeed. And Hugh back in the studio tells me that puts us right up into the higher rankings of podcasts globally, and with the numbers we've recorded in the last few years, we're probably one of the top 1% podcasts, which I think is just an extraordinary achievement. I'm totally dumbfounded that two old farts like us are getting that much attention. It's but it's terrific. So thank you to one and all for supporting Space Nuts, and onward and upward. We will show ingenuity in the future. In fact, we're going to talk about that shortly. We're also going to talk about the square kilometre array because our government, the Australian government's chucking in a couple of dollars. And when I say a couple of dollars, I'm being literal. No, I'm not. I'm just stirring the pot. And some bad news for those of us who were looking forward to jumping on the USS Enterprise and going to Warp Factor 1. Never going to happen. New research has kiboshed the whole thing. And we've got questions from Rusty and Donnybrook and Dealer from Toronto. And one more thing I need to add before we get started, Fred. Apologies in advance if you hear weird noises coming from my end of the spectrum. I've got landscapers here today doing a bit of work out the back, and they may be cutting pavers at some stage. They're wheelbarrowing them in the yard. I told them I was busy, I couldn't help. But yeah, they're wheelbarrowing from the front yard out of the truck to the backyard where they're putting the pavers down. We're getting a little barbecue area done. And the upper plateau of my yard, which has been a useless piece of land for a long time, I'm very excited.
Oh, good.
It's going to be a putting green. Oh, no. Talk about self-indulgence.
Oh, no.
I'll send you a picture. I know it's not space worthy, but I'll do it anyway. So there we have it. So if there's some noise in the background, just ignore it. They're not here. But first, Ingenuity, success at last. I tried to stay up and watch it, but, the thing about NASA, no disrespect, is if something's at 9 o'clock, it's 12 o'clock. So I just couldn't hang in, but I made sure I looked at it the next morning. Fantastic and a great success to get it off the ground, do a little bit of a hover, a pirouette and a landing. It was just all over and done in less than a minute, but it might have taken no time at all, but it was one of the great achievements in human flight history, I think.
I absolutely agree with you, Andrew. It was. It's a Wright brothers moment. And of course, the Ingenuity helicopter carries a little bit of fabric from the Wright brothers' first aeroplane, isn't it?
Yes.
The Wright brothers, not the White brothers.
Yeah, we keep this up. There's not going to be much left of the plane. That's the part that worries me.
Well, I've got a bit, I'm sure.
Have you? Ooh.
No. But it will be lovely. This is the first step in aviation on another planet. The next step will be another flight, which is a little bit more ambitious because they'll rise a little bit higher, I think, 3 meters or so, maybe a bit more, but also move forwards and backwards 15 meters. And I think there are 2 flights like that, just to check out that the aerial vehicle can move as the mission controllers want it to. And then the last of the 5, there are 2 flights left because it's a suite of 5 flights that they're planning. They will go far and wide. We don't know what they have in mind, but I'm sure we'll see some amazing images coming back from the surface of Mars. The one that I was most impressed with, there was a little movie that Perseverance itself took of the flight. Perseverance was 65 meters away, just to make sure, if things really went ballistic, the helicopter didn't clout the cameras or something like that. But there's a nice shot, only in black and white, as I'm seeing it at the moment, taken by the helicopter itself, looking down at its own shadow.
Saw that one, yes.
Yeah, it's great. It's fantastic stuff. And actually, you can see not just the shadow, but you can see the tyre tracks of Perseverance as well on the same shot. Fantastic stuff. And we believe that, perhaps maybe even when we speak next week, there might be more to report on what's happening with the Ingenuity helicopter.
The test I'm looking forward to, Fred, is towards the end of the mission when Perseverance unveils its Martian cannon and Ingenuity rises. But on a more serious note, and this is going to be a question without notice, but we did get a question, I think, via Facebook from somebody asking, in the test phases of Ingenuity on the ground, they had to try and replicate the conditions that they would face on Mars because of the completely different environment and the very, very thin atmosphere, less than 1% of Earth, et cetera, et cetera. How did they replicate the gravity situation? Did they do it with computer modelling? What was the go?
The question was from, I've got it in front of me actually, from Judd Brown in Sydney.
Oh, okay.
Hi, Judd. Judd's question is, yes, you can clearly compensate for the lack of pressure. You just put the thing in something like a vacuum with only 1% of the Earth's atmospheric pressure. But the gravity is harder to simulate. And so what Judd suggests is, do they come up with an atmosphere somewhere in the middle between Earth's and Mars? And I'm sure that is one of the tests that they did. They would have tested probably, with Mars atmospheric pressure and Earth gravity, because that's giving them a really tough gig. They've got 3 times the gravity they're going to experience on Mars and the atmospheric pressure they have on Mars. So I would guess they did that as a check to see where how it performed under those really arduous conditions. Engineers always design things to withstand 2 or 3 times the stresses that they're supposed to, and that will be the way they do that. But I think Judd's suggestion of putting an atmospheric pressure somewhere in the middle between Earth and Mars, that would also be a test that would be done as well. So anyway, the bottom line is that the test all worked, and so did the helicopter. So we're in good shape.
It did. Yeah, they got it right, and can't wait for what happens next. So fantastic. And thanks for the question, Judd, because I did want to throw that in when we talked about Ingenuity, and I remembered at the last second. Which is, one of my terrible habits.
It's a good trait. It's better than forgetting at the last second, which is what I do. And I did forget in talking about Ingenuity to mention that those transmissions that were received from the first flight actually came through Australia. They came through the Tidbinbilla Deep Space Tracking Station in Canberra, where our good friend Glenn Nagle was certainly talking about it quite a bit on the radio.
That's lucky because they only got electricity connected last week. So good thing.
Bad times. Anyway,
okay,
good stuff.
Yeah, there'll be much more to talk about in the future, in the very short future, regarding perseverance and ingenuity on Mars. It's all happening. All systems go at the moment. Right, let's move on to the Square Kilometer Array. We've talked about this many times, but we haven't really talked about the money. But we are going to now because the Australian government's chipping in a mere $387 million.
Yeah,
that's Australian. So in US dollars, that's $3.
It's a little bit more than that, but yeah, that's real money. I mean, it's this is an announcement that was made last week. I have to say that my colleagues, people I work with and amongst in the Department of Industry, Science, Energy and Resources, who put together the budget considerations and things, they were working flat out on this for the past few weeks, and certainly last week they were getting it all tidied up, and then the announcement was made on Wednesday, which is great. So what this signifies is the Australian government's ongoing support for the Square Kilometre Array project, which our listeners I'm sure will remember is 2 telescopes, an array of telescopes, 160,000 of them is the number. Am I getting that right? I think so. No, 131,072 antennas, which look like Christmas trees in Australia. That's the low frequency array. The mid frequency array is going to be in South Africa, where they have something like 60 dishes, which look at the slightly higher frequency range. So a two-pronged attack on the universe to build the world's biggest telescope, and as I said, this signals Australia's ongoing support for it. Of course, governments always have to put the positive spin on things like jobs and growth. Those are the mantras of governments all over the world. And indeed, this is really, there's big numbers involved there too. There are something like 350 new jobs being created during the construction period, the 10-year construction period. And then over the 50-year life of the project, because this is going to outlast you and me, Andrew.
Yes.
There'll be 230 ongoing positions. This is serious stuff. These are big numbers for the jobs that this gigantic project will build. And just to mention as well that two things. One is that it's not just Australia in this. There are, I think, 16 nations are now signed up for it, 16 member countries all over the world. Actually, I might just list them because it's quite an interesting bunch. Australia, Canada, China, France, Germany, India, Italy, Japan, Korea, the Netherlands, Portugal, South Africa, Spain, Sweden, Switzerland, and the United Kingdom are in there.
Wow.
You might notice one country that isn't in there is the United States, because their interests in radio astronomy don't really align with what the SKA member countries are doing. So it's not, it's not taking your bat and going home or anything. It's just a natural thing about the scientific endeavours of these countries. But to anybody who's listening to us in one of those listed countries, well done. Your country is part and parcel of the SKA community. And what I was going to say is that that investment that the Australian government has put in, it means that what you're doing is you're stimulating foreign income flows into Australia because of that. And certainly in the first 30 years of operations, they estimate 1.8 billion in foreign income will come into Australia. So very important stuff. And one final thing to mention is that there is a chunk of that budget, 64.4 million, in establishing a specialist supercomputing centre, which will be in Perth, Western Australia, to do all the thing about the SKA is it generates 10 times the current, or it will generate 10 times the current internet traffic on the whole of the internet, and they'll do that 10 times over. So you need these enormous computing centres to do that. It's very exciting stuff. I'm delighted we could get a chance to talk about it. And well done, Australia. That's that's me waving my flag for the country that is closest to my heart.
I thought that 64.4 million was going into the Fred Watson retirement fund, but I clearly was misinformed. But one thing about this, and I don't want to sort of overshadow it with politics, but the politicians are the ones that sort of fly the flag and get the accolades. But you got to give credit to the people that work in those back rooms in Canberra, in the Treasury Department and budgeting people that sort of figure all this out and work out, oh, we can afford to do this over this period of time through this avenue of funding. And they work so hard and they never get thanked. So thank you to the invisible people in Canberra that do all the pen pushing, that make all this stuff happen, because you deserve to be recognised.
Look, I'll be talking to them in a teleconference this afternoon, Andrew. I will pass on your message. Yeah.
I appreciate you, being an administrative person myself. I've done a lot of administration in my life.
Yeah, me too, in my time.
I find it therapeutic. I do, honestly.
Find it.
But no, it's good news. It's really good news. And I suppose we should, just for the sake of it, refresh people's memories as to what the SKA's role is going to be. What are we trying to achieve with it?
So it's remarkable. Its remit is the entire history of the universe, basically, because it's, the kinds of things it will be looking at are the dark ages, that time between the Big Bang and the first star switching on, when the universe had a lot of cold hydrogen in it, which the SKA will be able to not only detect, but to map it out, to see where it lay and how that formed the universe's growth. And then things like the origin of magnetic fields in the universe. That's one of the key targets of the SKA. One that I am very interested in and very keen on is that SKA will detect very large numbers of pulsars. These are neutron stars, spinning neutron stars, that essentially let us test gravity at very extreme levels. Neutron stars and black holes are the most gravitationally strong objects that we can see. And so what you're really interested in is looking at these objects in detail to see whether relativity still works at these high gravitational intensity levels, because relativity is our best theory of stuff in the universe, but we know it's got holes in it. We know it doesn't completely work. So that is, this is one of the things that in fact, I had in mind when about 2 years ago, I went before a committee, a high-level political committee, which was ratifying the treaty that the Square Kilometer Array, the international treaty that it's going to be built under. And I promised them Nobel Prizes, which might have been, I said they had my personal guarantee that this would generate Nobel Prizes, and that actually appeared in Hansard. But so it was not...
It's on record.
Not entirely a throwaway comment. Of course, at my age, you can promise anything, Andrew, but it's not a throwaway comment, because I believe that if the SKA reveals insights into the absolute fabric of reality that underpins all of relativity and quantum theory and everything, and it may well do, that will certainly generate Nobel Prizes. So all of the above, plus just finally, coming right up to date, the SKA can detect an airport radar at 50 light years. So who knows what we might pick up going on in our neighbourhood in the universe in terms of intelligent species.
Well, fingers crossed.
Yeah,
we can be hopeful, indeed. All right, you're listening to, and if you're on YouTube, watching the Space Nuts podcast, episode 249. Andrew Dunkley here with Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Thanks for listening to Space Nuts, the podcast about astronomy, space science, and all sorts of other stuff. Andrew Dunkley here with Fred Watson. Fred, I sent you a photo yesterday. I happened to be out in our sunroom and having just a nice quiet wine with my wife, and it was just sort of past sunset, but it was still a bit dusky, and I looked up and there was a half moon to the north. Due north, exactly north of our place. And I thought, gee, that you don't see half moons very often like that. And just something about it caught my eye. Not that I see very well, but I went and grabbed my little Canon digital camera, and it's got 40 times optical zoom. And I zoomed in and I held it steady as I could using the frame of the door to keep still, and snapped a photo. And it just came out beautifully. I've put it on the Space Nuts podcast group Facebook page for people to look at. But you can at the point where you go from light to shadow, it's just beautifully cratered, and the camera picked up those craters so vividly. I was surprised, but also delighted. It was I get lucky sometimes with my photographs. That was a nice one.
It's a lovely one, and classic first quarter image of the moon, of course, upside down here in the southern hemisphere, but right way up to us. No, it was lovely, and I think as of now, you need to rename that room the Moon Room rather than the.
Yes, well, yes, it's on the northern side of the house, so in winter we get the sun sort of comes straight into it because of the angle of the Earth. And it warms up nicely. So we can go in there and get warm in winter and not have to use heating. It's terrific. All right, to the saddest story of the year so far on Space Nuts. There will be no warp drive. It's impossible. Why? Why, Fred?
Yeah, well, it apparently doesn't work. So...
There you go.
That's it in a nutshell. The story goes back to 1994 to a physicist called Miguel Alcubierre, who essentially formulated how you could build a warp drive. Building on of course, the warp drive that Star Trek used 2 decades before. The warp drive could be a reality. There was a hypothetical way that used modern physics to demonstrate this twisting of space that lets you avoid the universe's speed limit. So that the speed limit, of course, says that you can only move through space at the speed of light. That's the maximum. But warp drives, like the Alcubierre one, if I'm pronouncing that correctly, seek to bend the fabric of space, if I can put it that way. So. And it actually got a lot of attention. A lot of quite serious institutions looked at this, but the calculations quickly turned out that the problem with it was that you needed more than the entire energy budget of the universe to make it work. And that sort of dampened enthusiasm down a bit. But there's been some new research. These are 2 physicists based in the USA, Alexei Bobrik and Gianni Martire, if I'm pronouncing the names correctly. They've looked at the warp drive again, and they've kind of worked out that even if you could make one, it may not allow you to travel faster than light. It may not bend reality in the way you want it to. And so that's been a dampener, but they've actually, the details of this story are that the technology that you might use if you could bend space could have other applications, some of which are quite intriguing.
Okay.
I don't really want to go into the details because I find this sort of stuff very hard to describe. But one of the proponents has sort of drawn an analogy here. That sounds like your paving stones being cut up there, Andrew.
No, they're actually using a leaf blower to clear off some of the mess they've made.
Just a leaf blower, yes. Okay. There's an analogy of saying that, a warp drive is a bit like a car, because what you do is you bend space around it. You twist space in front of it, sort of crush it all up and spread it out behind it. That's the idea.
Right.
And so that's the theory of the warp drive, and it's why people have thought that you could shortcut the distance because you've compressed the space in front of you, and the opposite side is stretching it behind you. So compressing the space, theoretically, at least that was the idea, would let you cross that space quicker, and so you exceed the speed of light. But the analogy that's been drawn is, as I said, a bit like a car, because it turns out that just like a car, which is a shell of material, what you do with the warp drive is you build a shell of warped space around yourself, and the space in the middle is okay. It's what we call flat space. It's kind of like the space that we're all sitting in now. But you've built this shell around you of the warped space, but it doesn't actually get you anywhere because the whole thing still moves at no faster than the speed of light. So that's the bottom line that they've uncovered. It, however, does suggest. Just going back a bit, there were other key issues with the Alcubierre device because it needs negative energy, which doesn't exist at the moment. That was one of the pitfalls with it. Even if you could find it, though, it turns out that it doesn't really work. But what they've suggested is what these new authors, Bobrick and Martiri, have suggested is that because you're using the space warping to modify the region of the bit of space that you're in, because what you're doing is you're kind of building a wall around a piece of flat space-time, a piece of normal space-time. You can use the other aspects of relativity, like time dilation. You can speed up or slow down time within the warp drive. There's some examples that have been. This is a Cosmos article I'm reading here that actually comes from the conversation, so it's freely available. But the author of this has suggested if you wanted, if you had somebody with a terminal illness, but you thought that they could be cured in a few years, you put them inside a warp drive and you slow the clock down. And then they sort of stay ill for a short time, but that few years or those number of years that they need for the new cure, that passes normally outside the warp drive. And that's the sort of thing that they're talking about. You could do the alternative thing. Here's a suggestion from the same article. Want to grow your crops overnight? Stick them in a warp drive and speed the clock up. A few days will pass for you and a few weeks will pass for your seedlings. It's an interesting thought. Still
That's amazing.
Still very much in the realm of theoretical physics, but some very nice ideas for this possibility. And I should credit the author of the conversation article. That's Sam Barron of the Australian Catholic University, somebody whose name crops up quite a lot in these sorts of considerations. Writes very well about these really quite difficult issues.
I suppose the big problem is even if we come up with a workable theory, the energy you need to create the possibility is beyond us, which prompts the question, what can we do at the moment? I know you and I have spoken about various forms of propulsion using laser to send miniature spacecraft to other stars, but it sounds like travel to the stars in short time through warp drives is not going to happen. But there was another, I think, discussion we had about the potential for nuclear power in terms of space travel. That would get you going.
It would. It does get you going. And so that's probably a viable alternative to the light sails that you just mentioned, using lasers to blast you along with a light sail. But of course, these are still all limited to the speed of light. So even if you're going at 99.9995% of the speed of light or whatever, it's still going to take you, 4.5 years to get to the nearest star. And if you're going fast enough, that the time dilation effect comes into play. Your 4.5 years trip, as seen from Earth, becomes just a couple of years for you, or perhaps 6 months or something like that. It's really interesting stuff.
Oh, it makes your head spin, but it brings back that twin theory about the.
Yes, the twins paradox.
One that stayed on the planet and one that did a trip and came back and hadn't aged, where his brother was 50 years older or something. But it actually, in theory, is a real possibility, isn't it?
Well, it's more than a theory. That actually works. We know that from the behaviour of subatomic particles. When they get near the speed of light, time slows down for them. So we see that happening.
But sadly, for all the Star Trek fans, there's no warp drive, never probably will be. We're going to have to find something else. Maybe if they get out there with some horticulturalists, they can find some wormholes.
Wormholes are what you need, that's right.
That's probably the solution.
But not horticultural ones.
No. We don't like to talk dirty on this show anyway. This is the Space Nuts podcast. Andrew Dunkley here with Fred Watson.
Space Nuts.
Now, I mentioned our patrons earlier on, and we thank them again for their support of the Space Nuts podcast financially. If you'd like to become a patron, go to our website, spacenutspodcast.com, and click on the supporter button and find out how you can become a supporter of the Space Nuts podcast. We're still working on ways to reward our patrons, and some new ideas are being tossed around as I speak, but we are going to be providing some bonus material in the next little while for our patrons. We've been a little bit lax lately in keeping up with the support of patrons, so we'll fix that. And thanks again for supporting us and being a patron. We so much appreciate that you're willing to put a few bucks in to the kitty. So thank you again. Now, Fred, time to answer some questions. We are going to hear from one of our regulars, the astute and incorrigible Rusty from Donnybrook, who, he can tell you what he's hoping to ask us this week.
Hey, Fred and Andrew, it's Rusty in Donnybrook. Still hungering for more detail in the big picture, and your show just fits the bill so well. Question for the day: what is the great attractor? Where is it? And will it affect our distant descendants?
Okay, thank you, Rusty. Lovely to hear your voice again. You mind if I have a crack at this one first, Fred?
I think you better do it, yeah.
The great attractor is the John Deere. I hear it's a superior tractor to most others. So
there you go.
Got a feeling that's wrong.
Well, it's better than the lesser tractor, isn't it? Which is the old Ferguson that we used to see everywhere, the grey Ferguson.
Oh, the Massey Ferguson.
Yeah.
Yeah. My great uncle was a tractor mechanic back in the day, and they specialised in Massey Fergusons. So he also used to fix my car, which he had to do a lot. But yes, but that's not the point. We want to find out about the great attractor. What is it? Where is it?
Yes, so it's two separate words, different from the greater tractor. It's the great attractor. And this is something we've known about, I guess, for 30 or 40 years now. Certainly, most of my career, I've been aware of this anomaly, which is basically what it is. It comes about because if you look at, I suppose we're talking about relatively nearby galaxies maybe within a billion light years. Okay, that's a billion light years is a long way, but within that region there are lots and lots of galaxies, and it turns out that when you observe them and observe their velocities, they of course are their movement is primarily dictated by the Hubble flow, the expansion of the universe. And the Hubble flow is what carries galaxies faster away from us the further away they are. We understand that because it's the way the universe behaves. So the Hubble flow is the first thing that you observe. But if you look in detail at these galaxies, you find, they have what we call peculiar motions. And a peculiar velocity, as we usually call it, is it's basically it's a velocity superimposed on the Hubble flow, if I can put it that way. The best way to think of this, Andrew, is the old analogy of a river flowing and carrying boats with it, but all the boats are rowing away, so they've all got their own motion, but that's superimposed on top of the flow of the river. And that's what peculiar velocities are in space. So these galaxies all have their own motion, which is superimposed on the Hubble flow. So you understand the Hubble flow, you can deal with that. That's the expansion of the universe. But when you've dealt with it, you've still got all these peculiar velocities. They've got their individual velocities. And what suggested the great attractor is that these peculiar velocities for a very large group of nearby galaxies are all in one direction. And the idea is that these velocities result from the fact that the galaxies are being drawn towards something called the great attractor, which is a gravitational mass. And it's almost certainly a cluster of galaxies, a large, probably a supercluster actually. But the problem is, it's behind the Milky Way. That's why it's always such an interesting thing to talk about, because it's hidden from us by the fact that we are looking, the direction in which it is behind, it's in the plane of the Milky Way. So it's not actually that far from the direction of the galactic centre, which is Sagittarius. I think I could probably say just where, I think it's in the constellation of Norma, the great attractor, which is one of the one of the Milky Way plane, galactic plane constellations. So really a really interesting feature of the universe, which has been discovered by astronomers carefully observing the velocities of galaxies. And their peculiar velocities range over quite a large set of values, from about positive 700 kilometres per second to negative 700 kilometres per second. So a range of around about 1400 kilometres per second. And it depends on where you are, in the sky. As you'd expect, I think the ones closer to the great attractor are probably moving faster than the ones further away. So you can do all these calculations. The second part of Rusty's question about will it have an effect on our distant descendants? Probably not, because we know the first thing that's going to happen in this sphere of understanding to our distant descendants is they're going to witness the collision between the Andromeda Galaxy and our galaxy, which is 4.5 billion years away. Yeah. So they are very distant descendants, and that will probably, it might trigger some local star formation, a few supernova explosions, and if they're nearby, they'll be a bad thing. But in general, it's not going to really be much of a threat to the solar system unless you get a nearby supernova, which would be. So the colliding, being drawn towards the great attractor, which we undoubtedly are in our galaxy, along with the rest of the local group, which includes Andromeda, the Triangulum galaxies, the Magellanic Clouds, all of that stuff. Even if we collide with the great attractor, it probably won't make much difference to what's going on in our own galaxy.
There you go. Of course, that's all going to take a long time, and we're just assuming that humanity will sort out all its differences and live happily ever after.
Of course.
And be around then. But, yeah, I got a feeling we might run into a few snafus before then, but hopefully not. But thanks, Rusty. Great to hear your voice again. Let's move on to the next question. Hello, Fred and Andrew. This is Dealer from Toronto, Canada. I'm a big fan of the show. Well, that's the first one I've heard of. I've been listening since day one. Oh, fantastic. Good on you. I've been meaning to ask a question, but have always delayed it. And now I've got a whole pile of questions stacked in my brain, but we'll spare you and ask only 18. No, 3. What makes Neptune invisible to the naked eye? How do they steer space shuttles in the vacuum of space? It's a steering wheel. And what is the universe expanding into? Thank you. You guys are amazing. By far the best duo out there. Keep it up and stay safe down there, down under in Australia, mate. Yes, we will. Thank you, Dealer. What makes Neptune invisible to the naked eye, Fred? You've written about Neptune.
Yeah, I have, yes. So Neptune's an interesting world. It was the first. Probably not quite true, actually. But following the discovery of Uranus back in 1781, I think it was, 13th of March, if I remember rightly. 1781, discovery of Uranus. People observed Uranus and realised that it was not behaving in a way that could be understood if all that you could see in the solar system was all that there was. Something was pulling it gravitationally out of its course. And mathematicians got hold of that, and in 1846 a prediction was made that said, look here for Neptune and you'll find it. And sure enough, that's what happened. I think it was Galle, the German astronomer who found it. I should know the details of all this because I've been writing about it, but never mind. So that suggests, of course, that Neptune is not visible to the naked eye, because otherwise, like Uranus, like Saturn and Jupiter, it would have been known since ancient times. And the reason is it's so far away. It's by far it's the most distant planet in the solar system. An object a bit smaller than Uranus, which is only just visible to the naked eye at certain times, and very much nearer than Neptune. So that's the bottom line. It's just too far away and too small to be visible with the naked eye. Of course, you can see it with telescopes. We've got lots of telescope images of it, but not naked eye visibility. How do they steer space shuttles in the vacuum of space? And
Good question.
A really good question, because when we think of aircraft, we think of control surfaces which bite into the air and steer the aircraft around. You do it with thrusters. In fact, you use little rocket motors which don't need air to push against. A lot of people think rockets work by pushing against the air that's in the atmosphere, but of course they work in the vacuum of space, and it's because the bottom line with a rocket motor is what you've got is essentially a spherical chamber with a hole at one end, and if you think of it, there's basically pressure inside it. So the pressure is acting; it's balanced everywhere in the chamber. The pressure on one side is balanced by the pressure on the other side, except the side opposite the hole, because where the rocket exhaust escapes from the nozzle at one end, you've got an unbalanced pressure in the opposite direction, because the pressure, you're not looking at a solid object, and it's that unbalanced pressure that forms the thrust of the rocket. That's what sends it off in its direction. I've drawn a cartoon on this, Andrew, in the new kids book, which is one of my favourites in the whole book. So it explains exactly this, why you don't need air to press against, but it's got a few other little bells and whistles on it as well. And finally, what's the universe expanding into? Big question there, and the answer is we don't know. The word universe means everything that you can detect or see, and so you don't really need to have anything for it to be expanding into, because there's nothing else, at least in the traditional sense of a universe. And so it is expanding, and we know it's expanding, and it doesn't have to be expanding into anything else. However, in this era of multiverse ideas, some people think that maybe it is expanding into a higher dimension, maybe a fifth dimension or something like that you've got the expansion taking place in, and perhaps other universes existing in that fifth dimension. But that's all really fairly, it's more conjecture than science, because we don't have anything other than people's ideas on this to support the view. There's no observations yet that support the idea of either a fifth dimension or higher dimensions or multiverses. But I have to say, just coming back to something we talked about a little while ago with the square kilometre array, the idea of new physics popping up out of that is the way we might find out about things like higher dimensional spaces and things of that sort. So that's why this is also exciting. Maybe one day we'll be able to answer the question with, yes, the universe is expanding into a fifth dimensional treacle or something like that, and give an answer to it. But we can't at the moment.
No, I got the feeling we're on the cusp of great discovery. It's just because of our advances in technology and the equipment that we can now create and the capabilities we have to put things in certain places in space or on Earth to look better out there. Not to look better, but to look better, to search better. We may well, we can't look better, we may well be able to start sort of piecing together more information that will ultimately answer the question. I don't think we're going to have a light bulb moment until we're right on top of it.
Yeah, that's true.
I think we're going to chip away at these things until one day we go, Oh,
There you
okay.
go.
Well, that makes sense. It's blancmange. But until then, it will be a slow, steady race requiring much patience, is my theory. But Dealer, thanks for your questions. They were good. I actually didn't really think much about movement of space shuttles until you explained it. I just thought, you turn the rocket on and it goes.
It does. Yeah.
Simple.
That's
All
why
right,
it goes.
Dealer, yes. Thank you for your question. Thank you, Rusty, and thank you, everybody. Now, next week is episode 250.
Oh, my goodness.
250. And now that we've surpassed 1 million downloads, what we want everyone to do between now and next week is listen to every episode over again until you catch up to today's, and then next week we can boast 2 million and something. I can't remember. Yeah, no, don't worry about that. But 250. So we're going to dedicate it all to questions, Fred?
Yeah, I think we should.
Sort of become our thing on round figures, hasn't it?
It has become our thing. Yeah. And 250, goodness, you don't get much rounder a figure.
So we will be answering 250 questions next week, or maybe, 8 or 10 if we're lucky. But please, if you have a question, you can go to our website, spacenutspodcast.com, click on that little AMA tab up the top, and in there you can either email a question to us or you can record one if you've got a device with a microphone. It's as simple as that. And don't forget to tell us who you are and where you're from, whether you're texting or voice questioning us. We would love to hear your voices, of course, but we take questions of all kinds, even emailed ones. So yes, next week 250, and boy, hasn't that? Yeah, it blows my mind. When we started, we thought we'd get 2.5 episodes in, but we're nearly there, 250. Awesome stuff. But that's where we leave it for another week. Fred, thank you so much for your insightful comment and knowledge and intelligence, and for sharing it all with us. We appreciate it.
It's a great pleasure, Andrew. Always good, and looking forward to the next time.
Indeed. See you then. Fred Watson, Astronomer-at-Large, part of the team here on the Space Nuts podcast. Hello to Hugh in the studio, who puts it all together with rubber bands and sticky tape. And from me, Andrew Dunkley, thank you again, and we will catch you on the very next episode of Space Nuts. Bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.